Hello there, my dear friends and fellow viewers. Continuing along with our series of helpful instructional tutorial videos about the LS brand M100 inverter, today we want to talk in detail about one more very useful and important feature of the M100 inverter. In this session today, we're going to explore in great detail together about the digital outputs or the relay and transistor outputs of the versatile M100 series inverter. The M100 inverter comes in two models, the standard model and the advanced model. In the standard model, it has one transistor output with Q1 and AG terminals and one relay output with A1, C1, and B1, C1 terminals. The A1 and C1 terminals serve as the normally open relay output terminals, which are open under normal conditions, and the B1 and C1 relay output terminals are the normally closed ones. But in the advanced model, the M100 inverter doesn't have a transistor output and instead has two relay outputs. The first relay output is A1, C1, or B1, C1, and the second relay output is A2, C2. But the parameters related to the relay and transistor outputs in the M100 inverter, if we want to configure its digital outputs, meaning the relay and transistor outputs, we need to go into the OU parameter group, or OUT, which is related to the inverter's outputs. In the specific parameter setting OU31, you can configure the first relay output of the inverter, and in parameter number 32, you can set up and define the transistor output for your system. If your inverter is the standard model, parameter number 32 is related to the transistor output, and if your inverter is the advanced model, parameter number 32 is related to the runner relay. But how should we set these parameters? For a practical example, let's look at the M100 series inverter. If you specifically want the M100 inverter to automatically activate its internal relay output the very moment that the inverter starts up, that is to say, for the inverter to provide us with a functional relay signal, you will first need to manually set the specific value of this parameter, which could be either OU31 or OU32, to the value of 12. In this detailed instructional video today, we fully intend to set the OU31 parameter, which is directly related to relay number 1, to the value of 12. If we configure the setting to the value of 12, the internal output relay of the inverter will activate as soon as the inverter begins its operation. If we have chosen to use the normally open output relay, it will close immediately, and if we have used the normally closed one, our relay will open. But how exactly will our physical wiring configuration look in this scenario? If we want to use the transistor output and connect the signal lamp to our transistor output, one side of the inverter's 24 volts is connected to one side of the signal lamp, and the other side of the signal lamp is connected to the transistor output Q1. The common terminal of the transistor output, which is the EG pin, is connected to the CM terminal. But if we use the relay output, we can connect either 24 volts DC or 220 volts AC to it. The wiring is similar to the transistor output, but here we use terminals A1 and C1. C1 is also connected to the inverter common, which is the CM terminal. And that's our wiring. Now, let's go ahead and apply the settings we've learned to the M100 inverter and test the digital output, or the relay output, of the M100 inverter together. So on the M100 inverter, as we said, to configure the digital outputs, or the relay outputs, we need to enter the OU parameter group. Parameter number 31 is related to relay 1. We said that we want relay 1 to be activated as soon as the inverter starts, so that the signal light we've connected to the inverter turns on. In order for the inverter's relay to be activated as soon as it starts, we said that parameter number 31, OU31, should be set to 12. We set it to 12 and confirm the selection. Now I've defined my output relay 1 to be in run mode. If I start the inverter, the signal light that I connected here should turn on. I'm starting the inverter. You can see that as soon as I start the inverter, my relay 1 activates and my signal light turns on. Now, if I stop the inverter, after the inverter's frequency drops to 0 and it stops, my output relay will deactivate and my signal light will turn off. I'm stopping the inverter. As soon as my frequency hit 0, my output relay deactivated and my signal light turned off. So we've learned how to properly configure the output relays of the M100 inverter.